I'd like to welcome Shiv Sikand, co-founder and VP of Engineering at IC Manage. Shiv is a chip designer in his heart and soul, but extremely passionate about, making sure you can tape out these large designs, that you can do an IP-based methodology, that you can manage your designs and track your bugs and make it successful and not mess it up. I believe that he's probably the most knowledgeable person on the planet in this space, since he's devoted pretty much the last 12 years of his life to nothing else. But that's just my personal opinion. With that, please join me in welcoming Shiv Sikand.
Well, I think John Cooley once called me the most boring man in EDA, so I'm actually proud of that title because someone's got to do it. So one of the shifts that we're seeing with IP-based design is that there's a lot of different groups involved, right? And you're not always in control of the individual schedules of those groups. In the old days, when we did, single large chips, you had full control of it, and the tape out was done, by the group that owned all the IP in that SoC or in that big design. Well, that's not true anymore. You have to rely on data coming from multiple sources. And what you heard from, our customers here today is that these guys are, were able to go to, mostly monolithic systems. But in many large companies, it's not always possible to get everybody, online and transition to a new system because of these, complex schedules, particularly when you've got very large and diverse product families that have to share all this IP. So one of the things that we've introduced recently is the metadata manager that allows you to communicate with disparate repositories across your enterprise and to essentially perform what we call not only multi-protocol, but multi-protocol, multi-repository configuration management. So, most of these systems have some form of configuration management built into them, but when you have to, obviously you can try and consolidate into a single system, as many of our customers have done, but as you move forward into, a lot of these complex environments, you want to be able to do it across multiple repositories which may run their own, protocol. So the central IP repository has evolved from being, a single monolithic system, but to have the ability to do that across multiple systems. The binding between, a bug tracking system and data management system is critical, as we've heard, because not only does it help you figure out which bits of the design have been changed and why they were changed, or how you plan to change them, as Nigel mentioned, but what it also allows you to do is bring a level of metadata access that you didn't have before. And that is the ability to do what-if scenarios, which is to say that if I changed this IP to a different version, which new bugs were found by the regression team, and also which bugs have been closed, so you can take a decision on whether or not you should update to that latest IP. Many companies who don't have, powerful data management disciplines, they run on the latest model. Like, we got to always run the latest because, we can't take the risk of, uncovering something that somebody already knew. Unfortunately, those companies, have delays in when they tape out, because if you're always waiting for latest and someone releases something and says, okay, here's the latest, you got to go use it, you are exposing yourself not only to schedule delay, but also to risks that there are certain defects in there which may not apply to you. There may be a particular mode in there, or a particular mode set or register that you don't really care about. And therefore, you can use the older one quite clearly. So having that knowledge of why stuff changed and who changed it and the reason for that change, happens by having that binding into the tracking system. So once you have that, and you have that level of metadata access, you can actually use it to generate what we call roll-up reports. So you can actually look and create these new configurations without having to build the workspaces, without having to do all this complex assembly. You can do that all at the metadata level, and you can get your roll-up reports and say, what would happen if I changed these versions of these IPs? What would my new roll-up look like? So that's a very key advantage to tying the two things together. As Yaron mentioned, when you encapsulate your data together with your objects, so rather than having file-based systems, most of the legacy data management systems are file-based. We support more of what we call the object-based model, and that allows you to attach, not only your design properties of how things change, but constraints that go along with it, certain operating conditions, rules, and also your verification information that includes your test benches, your assertions, your dependencies, and then finally tie that all into a set of checklists. And again, finding that balance of checklists being a gate versus being more of a guiding thing, because often you may get a block that's incomplete, and it's okay to use that block knowing it's incomplete, but knowing that it's incomplete is important, that if it ends up with a bunch of DRC errors, it's okay because you were told that it's incomplete and you know why it was incomplete. But you can still use it, and you can use it for floor planning, you can use it for early timing reports, you can use it for early delay estimation. So it's important to get that information, so that same release early, release often methodology is important, but along with it comes additional information that helps you use it effectively. Now these numbers on this pie chart were from a survey, and it shows how much time people spend on verification tasks. So managing bug dependencies, 17% of the time is taken. And again, you can reduce that dependency management of that. I don't think you can bring it down to 0, but you can certainly improve it quite a lot from 17%, because you have that metadata automatically in the system, you're binding it all together, and these reports are being generated through design automation. It's not being managed through through hand editing and creating spreadsheets and doing things like that. Then, test benches, people spend 26% of their time on them. If you can reuse those, you can reduce your redundancies, and you can do it with fewer people and in a shorter space of time. So again, being able to carry that test bench information along with your objects helps you a lot. Now, if we look at the debugging time, you can see that it's split between managing your bug dependencies and identifying those bugs. And again, that same level of encapsulation allows you to tape out with known bugs. Of course, as Yaron mentioned, sometimes you are going to tape out with known bugs, but at least you know what you're doing, right? You take that risk, and it's a calculated risk instead of a guess. So you can also reduce your verification tool usage, because you're no longer continually re-verifying the same IP, particularly if you use the reference model. But even if you use the integration model, where you're branching, creating derivatives, that information flows across into the derivative because we maintain that relationship. Okay, so that's kind of where I'm going to sign off, and thank you very much.
So we do have some customers, of course we built that feature essentially because that was the requirement of our customers. So the focus is on metadata encapsulation. So your underlying system runs the same. So let's say in the clear case, as long as you're not running dynamic views, right, you can share that IP more effectively, because the way the IC Manage protocol works is it just calls the native underlying system to deliver the content. So what it does is it allows you to record the release information and the construction information in the metadata manager, and when you want to go in and extract it, it's really just talking the underlying protocol of the third-party system. So in that case, it'll call clear tool or set view, run it, and build your workspace for you. And then it allows you to do that across, multiple, domains. But more importantly, what it allows you to do is to get configuration management across those hybrid systems. You can say, look, I want this block from ClearCase at release 7. I want this other thing that comes from SVN at release 9. I want this other thing that comes in, in a different protocol. Maybe that's CDS, maybe that's native IC Manage. But one of the things that we started developing is we started doing that for a set of customers, and then they said is that since they no longer have control over that foreign repository, as it were, they don't know if that's going to go offline, because that IP producer doesn't really know how the IP has been consumed downstream. So what they wanted to do was initially use that to capture the design, build the SoC, but once they built it, they want to re-import that into a single system so that they have to rev it or make changes to it. The SoC team were in control of that. So there is some evolution there about how you use the hybrid model.